Hi, today we're going to start chapter 10 about similarity. We're going to start out with just some vocabulary. A ratio, according to your textbook, is a number A to a number B. And guys, this is just a comparison between two numbers. This is just like a fraction, okay? So anytime you have a fraction, so 2/5. My pen is acting weird today. Okay, that's a ratio. Now, whenever you have two ratios that are equal to each other, that makes a proportion. Now, when you have a proportion, when you multiply upward, this is called your mean. So technically, this one down here is your means as well. When you multiply downward, this is called your extreme. Okay, so this is proportion. And so this is just a way for me to say, hey, what are the two values of your means? And you know exactly what I'm talking about. One way to remember which one is your means and which one is your extremes is at least when I make an M, I go up, down, up, down. And so that's one little way that you can remember which one is your means, and that means the other way has to be your extremes. Now, we're going to talk about the next thing is called a geometric mean. Now, the geometric mean is when your means are the exact same value. So, for instance, they would both be the value of b, or they both be the value of x, or whatever number you pick. Okay, so we have three different things already. We have a ratio, which is a fraction. We have proportion, is two fractions that are equal. And then we have a geometric mean. So this one, notice the means are both 10. So 10 times 10 is 100. And so multiplying the other direction, it also has to equal 100. Now, not to get way ahead of ourselves, but later you're going to learn how to find the geometric mean when I give you a picture of a triangle. That is not today, okay? We're going to take some baby steps here. So first, I'm just going to give you like two numbers, and you're going to find the geometric mean. Later, you'll figure out where those numbers are on the triangle. Okay, so here in green, this is the geometric mean of a number B is the geometric mean between the numbers A and C. Okay, again, they just have to be the same. So if I asked you, and my pen is acting silly, to find the geometric mean between 3 and 27, those go in the means location. X's go in the other location. And so x squared equals, I believe that's 81. And then you're going to square root both sides. So x is 9. And you could test this to make sure it works. So if I were to get rid of the x's and replace them with 9s, do you get the same answer? So when you simplify these, 3 goes into 9 3 times, 9 goes into 27 3 times. They're the same fraction. Okay, now for the next one, it says find the set of numbers for which 10 is the geometric mean. Okay, so let's make our fraction. Come on, pen. 10s go this way. So 10 times 10 is 100. So really, we just need a combination that multiplies to give you 100 that goes in the other direction. So really, is it 1 times 100? Doesn't that work? Because 1 times 100 is 100. Now, guys, there's going to be lots of combinations here. Tell me, think to yourself, what's something else that multiplies to give you 100? How about 2 and 50? That's 100, and that works. Again, there's more choices here. All right, how about 5 and 20? And you can see if you simplify these, you have equivalent fractions. Actually, they're proportions. Okay? So find a set of numbers for which 50 is the geometric mean. Okay, let's try this. So it's going to be just like what we did up here. So we have 50 and 50. And I'm sorry, my pen, it was dropped and I think it might be broken. Okay, so 50 times 50 is a big number. 2,500. Okay, so we just need two numbers that multiply to give you that. Okay, so how about 25 and 100? That works. And you get 2,500. Now we need three combinations. Okay, so we have 50 and 50. And you can grab a calculator and see what goes into 2,500. So 25 and 100. Let's just do 5. So 5 and 500. And we have one more. So 2,500 divided by 50. Oh, I mean, I guess technically that works. 1550. I'm not going to use that one. That one's silly. Okay, 2,500 divided by 2. 2 and 1,250. Okay. Now, similarity. Now, I don't think we've actually defined similarity. So let's do that. Similarity is two things. It's when your angles are equal in measure. As you can see, my pen is just not wanting to do it. Okay, and the sides are proportional. Okay, good enough. Hopefully you understand what I'm trying to say here. Okay, so think of a photocopier. If you put a right triangle on the copier and you make it bigger, the angles stay the same. It's still a right triangle. It doesn't magically turn into an obtuse triangle. But the sides all grow at the same rate, right? And so it just turns out bigger, but the angles stay the same. Okay, so if you look at this picture, there's really two triangles here. There's this tinier triangle, and then we have this bigger triangle out here. And technically, they're similar, okay? So that means all the angles are the same, but the sides are proportional. Now, the good thing about this one is they give you the proportion. So all you have to do is look at the picture and plug in the values. We'll, again, learn later how to set some of these up on your own. So AB is 20, BD is X, AC is 16, and CE is 9. All right, so grab your calculator. So let's multiply those means and get 16x equals 180. And when you divide by 16, x is 11.25. And we're going to complete the ratio. Actually, it's more like complete the proportion. Okay, so what could be over here? Now, you're using this first one, and then you're going to use that to help you with the second one. I'm going to give you a second, I want you to attempt it, and then we're going to go over the answer. Okay, so hopefully you've tried it. The answer is going to be 6/2. Lots of ways to get this answer, but it has to be 6/2. If you put 2/6 or anything else, it is incorrect. The main thing I like to do is check those means and extremes. When you multiply, are you still multiplying the same two numbers? And you are. When you multiply up like this, notice you're still multiplying the same two numbers. They're just flipped, and that's fine. So, is the last one down here, is it true or false? And it's pretty easy. Just check the means and extremes. Are they the same? So 15 is being multiplied by R, so that's the same. And 6 and S, and that's the same. So this is true. Okay, that is it for today. And let me know if you guys have any trouble with your assignment. Thanks.